Proportion is the equality of ratios. There are different types of which require corresponding solutions. Learn them here in Mathematics of Engineering. There are five main types of proportions. They are direct proportion, inverse proportion, partitive proportion, compound, and continued proportion. The other proportion is more on the characteristic resembling the third proportional. This is the invariant proportion. The first type is the direct proportion. This includes two quantities x and y, where the trend of one is also the trend of the other. Say if x increases, y also increases. Some examples of this proportion are the first characteristic of a concrete sample under loading. While a bigger load is applied on the concrete, it experiences more stress. Another is steel bars. Smaller diameter of steel bars would provide lower tensile strength. The second type of proportions is inverse, which is also called indirect proportion. This is a type also having two quantities x and y, but the trend are reciprocating. That means that if x increases, y goes down. Some examples of inverse proportionality in civil engineering are the relationship of the water content of concrete mix. The more water added, the strength of the mix will be reduced. Another is the relationship of the soil strength with the depth of the foundation. The weaker the soil, the deeper the required foundation will be. The next type of proportion is partitive. This type is when a whole is divided among a number of elements, but what is given is the ratio of those elements. Visualize it as a pie, where the pie will be divided among three persons, with the ratio 1:2:3. Then there is also compound proportion. This is a complex type as it includes two or more quantities. In order for you to imagine this type, let's take the case of construction work. The premise will be giving not only the number of days and the number of men, but there would also be something about the number of hours. The last main type is continued proportion. This is proportion which deals with relationships of different ratios of terms. Specifically, the ratio of the first and second terms would be equal to the ratio between the second and third terms. Mathematically, the concept is written as A over B as equal to B over C. This is the relationship when the proportion only has three proportionals, or when there is a mean proportion B. The last type of proportion is invariant proportion. From its name, it denotes that something is constant or not varying. This proportion keeps the quotient of quantities as constant. Examples for proportions are showcased in the next videos, but we continue discussing the rules in solving compound proportions here. We just discussed earlier that compound proportions could have two or more quantities. Take the standard three quantities in the discussion. Quantity 1 would have the ratio of A:D. Quantity 2 has B:E, and quantity 3 has C:F. The first case includes the first and second quantities as directly related. Then the second and third are also directly related. The rule to follow in each fraction form is A times B over C is equal to D times E over F. The second case of compound proportions is when the first and second quantities are directly related, but the second and third quantities are inversely related. The equation to use is B multiplied by C over A, and this is equal to E times F over D. The third case is the opposite of case 2, where the first and second quantities are inversely related, whereas the second and third are directly related. The equation for this becomes A times B over C as equal to D multiplied by E over F. The fourth case considers the first and second quantities as inversely related, so are the second and third quantities. The working equation for this is the product of A, B, and C with D, E, and F.